Hey guys, and welcome to this lesson all about a skill called completing the square. Now, what is completing the square? It's a really important skill, and it's actually a kind of confusing skill. And before we go into that skill in particular, let's kind of motivate how and why that skill is helpful for us. And to do that, I want to kind of go through the motions of solving some polynomial equations. And in specific, I want to solve some quadratic equations, meaning the highest exponent our variables are ever raised to is the second power. And I think the number one strategy for me for solving polynomial equations is if I can factor, I like to solve by factoring. So I'm looking at this first example, and I definitely think that this trinomial here factors. Maybe you know how it does already. I think it factors as the quantity of x plus 7 times the quantity of x minus 4, all equals 0. And now that it's nice and factored, I think the two solutions to this quadratic equation are going to be x could equal negative 7 or x could equal positive 4. Life is good. So I think strategy number one that I like to use is if we can factor, let's go ahead and factor. And I kind of put these down here. Oh, nice. So number one strategy is factor. Always try to see if you can factor when solving a quadratic or polynomial equation. Okay, let's see. Does this polynomial right here factor? Yeah, I think it does. I think that this factors as x plus 3 times the quantity of x minus 3. I think our original polynomial was a difference of squares. Life was good. I think this means we could have two solutions. X could equal negative 3 or x could equal positive 3. Everything's groovy. But I do want to highlight an alternative strategy that one could use to solve this equation. I'm just going to kind of write it again right here. X squared minus 9 equals 0. I think you could add 9 to both sides of this equation, and you'd have x squared equals 9. You've isolated, in this case, an x squared. And from here, you can either use intuition and say, listen, what number or numbers square to give 9? Well, I think those two numbers are 3, right? 3 squared is 9, or negative 3, right? Negative 3 times itself is also 9. Sometimes people like to write this as x equals plus or minus 3. If you're into that, go for it. I prefer to kind of list it out. So another strategy we can use is to kind of isolate x squared. That is another strategy we can use. If you can isolate x squared, you can probably factor anyway, but hey, it is another strategy, so I think it's important to at least acknowledge that. So isolate x squared, and then kind of go from there. And this is something we're going to build on a little bit, isolating something squared. In fact, check out our third example right here. We have something squared equals 16. So I might even say, oh, well, if this thing, we'll kind of highlight this in purple, if this thing squared is equal to 16, then that thing itself could equal 4, or that thing that was being squared could equal negative 4. Right? Those are the two numbers that square to give 16. So I think right from this step, you could say, oh, well, in that case, x plus 3 equals 4, or x plus 3 equals negative 4. Oh, very cool. Of course, that means that either x equals 1 or x equals negative 7. And note that you could substitute either of these back in. 1 plus 3 is 4. 4 squared is 16. Negative 7 plus 3 is negative 4. Negative 4 squared is 16. So very cool. We had a situation here where you had not just an x squared like before. You had something squared equals a number. A note to self, if you wanted to, you actually could have, in this case, now this is not always going to happen, but in this case, you actually could have multiplied out the left-hand side of this equation. X squared plus 6x plus 9 equals 16. We could have subtracted 16 from both sides of the equation. And, we're just trying to do this by factoring. X squared plus 6x minus 7 equals 0. This polynomial factors as x plus 7 times the quantity of x minus 1 equals 0. Aha, damn. We find that, again, x equals negative 7 or x equals positive 1. The exact same solutions that we had found before. So it happened to be in this case that for this polynomial, you could solve it by factoring. Or you could solve it by using even a new strategy where you isolate x, something squared equals a number. Like x plus something squared equals a number. So I'm actually going to put that as our third strategy, and this is kind of going to be the one we hone in on a little bit. So isolate, I don't know how to write this, I might just say x plus blah squared equals a number. Of course, on the right-hand side, or the other side of this equation. You don't want to have any x's or blah, blah, blah over here. Right? You want x plus something, I don't know, 4, negative 7 squared equals just a number. Okay, so let's take a look at this last example. And this is the one that's going to kind of motivate this skill called completing the square. So in this case, I just want to show you that if we tried to solve this by factoring, we would fail. Right? I'm going to actually expand the left-hand side. X squared minus 8x plus 16 equals 7. I'm going to subtract 7 from both sides of the equation, yielding a new polynomial that we'd like to factor. X squared minus 8x plus 9 equals 0. And if we try to factor this polynomial, bad news, doesn't factor. At least it doesn't factor using rational numbers. With the skills we have, we cannot factor this polynomial. We are kind of out of luck. No dice. Wow. But what's really interesting is that this polynomial equation here, as we know, is equivalent to this polynomial equation here, is equivalent to this polynomial equation here, and this one, I think we do know how to solve. We definitely can solve using this form of this same polynomial equation. I'm going to go ahead and move that off to the side. Right, we know that we can take the square root of both sides here. And if you tell me that something squared is equal to 7, well, I think that something could be equal to the square root of 7, right? Because the square root of 7 squared is 7 by definition. Or that something could be the negative square root of 7, right? The positive square root of 7 multiplied by itself gives 7. The negative square root of 7 multiplied by itself gives 7. And check it out. That means that, well, x minus 4, that thing from before, could equal the square root of 7. Or x minus 4 could equal the negative square root of 7. Adding 4 to both sides of the equation here, well, we have a solution. One solution to this equation is x equals 4 plus the square root of 7. Hot damn. Right? There's no easier way to write this number other than 4 plus the square root of 7. But that's a solution. Or x equals, I'm going to go ahead and write in plus 4, x equals 4 minus the square root of 7. That is our other solution. And heck, you could even confirm this by substituting it in, right? If you have 4 plus the square root of 7 minus 4, well, 4 minus 4 is 0. You have the square root of 7 squared, which is 7. Amazing. And similarly here, we would have the negative square root of 7 squared, which is 7. And so the skill we're going to be talking about, the completing the square skill, is going to come up in situations like this. Imagine you were given a polynomial equation like this that does not factor. This one right here, it does not factor. And I'm just going to kind of rewrite this a little bit. Ooh, that's a little too large. X squared minus 8x equals negative 9. I just subtracted 9 from both sides here. And the skill we're going to be talking about, is how do you take something like this and add a number to make this into a perfect square trinomial, right? Here is a perfect square trinomial. It was a perfect square, which allowed us to, transform this polynomial equation into a form that we could work with. That's amazing. So the whole crux of this lesson is how do you take something like this, add a number to it, and make that into a perfect square trinomial? And we're kind of familiar with perfect square trinomials. That's what we're going to do. So actually what I'm going to do is I'm going to venture away from these guided notes for a second onto an algebra tiles thing that I made, which I really think is going to help with this.